All right, so today we're about cosine curve. Let's just do a little quick review. If you guys have this, everybody know what the amplitude is? 3. Good. The amplitude is 3. What's the frequency? 4. Good. And for your period, Frida, what's the formula?
2 pi over 8.
Perfect. Who knows the b value? 4. Good. All right. So just make sure you want to reduce these. Pi over 2. Awesome. Good. All right. I just rewrote like basically the same thing as you guys did with the sign, just so in case you had notes you were using, you can kind of follow along. It looks, the cosine curve formula looks almost exactly the same thing as the sine. Yeah.
Wait, so it's when you do the formulas, is it always going to come out to something that's going to be like on the graph, like pi over 2 or 3 pi over 2?
No, it could be like pi over 3.
Okay, so
yeah.
It's not supposed to like formula.
No, not all the time, but for what you guys would do it, like if you were actually going to graph one, so make it nice. But I've never used any graph one before, so I got a class to do it. Okay, so amplitude, guys, for the cosine curve, Frida, is the same thing, right? Number in the front, frequency, b value, right? Period's the same formula. All right, so phase shift, like what you asked me in the beginning. Right. When you guys see something in parentheses with the x, okay, whatever's added or subtracted, that's the horizontal shift. If it's a minus, it goes to the right. If it's a plus, it goes to the left. The vertical shift is the plus, either at the end or at the beginning. You could have like d plus or at the end plus c. Okay, that just moves it up or down. So all this stuff, guys, is the same exact thing as when you did the sine. We're going to be graphing in radian mode and doing our zoom trig again.
Why is there a d here and not a d anywhere else? Is there a d on the last one?
Yeah.
We used the ones like plus 30.
Yeah, there's like, remember that max or that altitude or something?
Oh, yeah.
Question, we got to move it up. 30.
Can there be a d without a c?
Yeah. Yep, there can be a d without a c. All right. So, a couple things that are different between the sine, bless you, and the cosine curve is that the sine curve. Do you guys remember where does the sine curve always start at?
0.
0. Good. Always starts at 0.
Oh, and because it's like on that side, it starts at 1. Cosine.
Yes, good job. Thank God. All right. Now, cosine, and I want to be careful with like this idea. I should say more that the cosine, it's going to start at 1 because of the unit circle, a general cosine curve. So we looked at this yesterday, kind of, why it looks like the way it did. It's because at 0 degrees, okay, your cosine was 1. So that's your first little point. So it's not starting at 0 anymore. Now, when we went to 90, or that pi over 2, the cosine was 0. Same thing over here at the 180, you were down at -1. Right? And 3 pi over 2, we were at 0. And back at 2 pi, we're back at the +1. So you still are going to get these waves, but the cosine curve, a full cosine curve, you can kind of imagine it almost like a horseshoe. Right? This is going to be one full cosine curve. I should kind of end it right there. So it's a little bit different. Now, a general cosine curve has a 1 as the amplitude. So make this little note on your paper. Cosine curve starts at, I put 1 here just because when it's general, it's 1. It really starts at the amplitude. Amplitude.
So then if the amplitude is 1, it doesn't zero?
Right. So if I put a 2 here, like y equals 2 cos x, we want to start at 1, it'd be starting at like 2. You would see something that looks like this. It'd go up to 2 and down to 2.
Oh, that's why it's usually only 1.
Right.
Because in the graph.
Exactly. Okay. So we're going to do kind of the same thing as yesterday, but I don't need to explain, what the period represents, what the frequency is. So today should be pretty quick, almost the same exact thing. All right. So if I asked you guys what is the amplitude of the graph of cos 2x? What do you guys think? Harley, I don't know her. Do we know this or no?
Yeah.
Yeah. Okay. 1. Okay. Who's not answering? amplitude's 1. Same thing for your period. Why don't you guys see what you think? Figure it out. What's the period that would be? Theta, guys, is like an X. Think about theta like that. I know. So 2 pi over 3. Your choice 2?
Yeah. Hey!
All right. This one's a good. I kind of like this question with the multiple choice. They need to do 2 things. So which one of those has an amplitude of 2 and the period is going to be pi?
I don't know.
The amplitude is 2.
Thank you.
The period is pi.
I got it.
Oh, you guys are good at this. Alright, what is this? You put 2 pi over 1.
Oh, so that's why.
Alright, what did you guys get for 3? 1, 2, 3, or 4? 1. Good job. This one's easy. You at least get the amplitude's 2. You know the number in the front has to be 2, so it can't be that one. Now, if you're doing 2 pi over b, 2 pi over b has to equal pi. So the only way to get that is your b value here has to be a 2. Okay, exactly. So it has to be choice 1. Yeah. Alright, a little bit trickier here, so you guys can kind of see some of these curves in action. Right, and we're going to be using a lot of the same techniques as you guys use the sine curve. So first thing we want to notice here, to tell, because we have a mix now, sines and cosines here. Alright, so you want to decide, is it a sine curve or is this a cosine curve? Look at where you're starting. What do you think, Adam? Only can answer this question. Is it going to start at, is it starting at 0?
It's cosine.
How come, Rita?
Sorry.
That's okay. How come?
Oh, because it starts at the amplitude and it doesn't start at 0.
And it doesn't start at 0.
And it doesn't have the other curve.
Yeah, it's nice, Frida. Those are all great. Okay. If it starts at 0, guys, it's going to be a sine curve. This one does not. So it has to be cosine here.
Wait, can cosine go up? No.
Go up?
Well, that's like the amplitude is like basically the same thing, kind of.
Yeah. So if you guys are going to look at the amplitude of a graph like this, remember how yesterday you cut it down the middle? And you so now then look at the middle here.
It's the amplitude, so it goes up too, but it just starts there.
Right, it just starts at a different spot.
So it's gonna, yeah.
And those are all going to be.
I just have to check.
Yeah.
Why does it start at 2? Okay, so it's like it always starts at 1.
So it's like this.
General. It starts at 1 if it's just like y equals cos x.
Yeah,
Why
right.
was it 1? Well, why was it y equals sine x? It would, but sine, it started 0. But if it was like 2 sine, it would still start at 0.
It's because it's part of like what sine is. Okay, here's why. Here's the big thing behind it. That's a little bit. No, this will make sense, I think, to you. Okay, do you have a calculator?
I do.
Okay. Here's where we get some paper. Really cheaper. Alright, so here's your sine. Here's your cosine. Frida, your question is really good. Okay, so if I did y equals sine of alright, so put your calculator though back in degree mode for this if you're going to test this out. You're asking like, well, why when there's numbers in front, why do you still start at 0, right? So if we type in all 3 of these, see what you get as your answer.
They have to be in.
Make it in degree mode though.
Mine doesn't do.
Did you get 0 every time?
It just doesn't show it right.
Oh, sorry. I should say like, never mind. Hang on. I should have been more specific when I was asking you guys.
Oh wait, maybe because I did it.
No, it's okay.
No, I didn't either.
Okay.
No, I should have. Alright, so if we go to degree mode,
Yeah.
Alright, so I should not have told you guys you're not graphing it. I just want you to like evaluate it. So if you had sine 0, let's type this again. What is the sine of 0? Sine 0 is 0. Now if I did 2 sine 0, what do you guys get? Good. Same thing. 3 sine 0 is still 0. So does that number in front change where you're going to start for sine? No. Okay. So now let's look at the
the 2 cosine 0 would be 2. Oh.
Okay, so now let's look at the cosine one. This might make more sense now. So now if you took cosine 0, and then I took maybe like 1, or not 1, the same thing. Then I did 2 cos 0 and 3 cos 0. Let's see what we get now. Okay. Cos 0.
So everyone's front is where you started?
Right, exactly.
Is it different when you put it in degrees though?
Well, if you try to evaluate this in radians, a lot of the computation won't work.
Because of the time. So for most
Right.
of the trig that we do except for this is in degrees.
Yeah, everything you guys should ever do is always going to be in degrees unless you are graphing. Like unless you physically are putting on a calculator like the graph of a picture of a paragraph.
What if it's like when we wouldn't be doing that?
No, you guys don't do that. But see how this affects where you guys start?
Yeah.
Like the number in front now? Does that make more sense?
Yeah, there's a lot.
Okay. It's because you're really evaluating that point on the unit circle. Good question. I'll put this picture back. Okay. So now that you guys kind of understand that part of it, so what does our amplitude have to be here? 2. Good. All right. So we have an amplitude of 2. So that means the number in front has to be a 2. A lot of times, just by knowing what kind of curve it is in the amplitude, you guys can figure out your whole thing. Right, so we knew it had to be a cosine, so I can get rid of the sine. And my amplitude has to be a 2. Right, we only have what? 2. Yeah, that's it. Now, if you guys look at the d value here, the frequency is 1. Right, that's still going to hold true the same property as you guys did when it was the sine curve. That from 0 to 2 pi, we see one full curve. The only difference is what they look like. Cosine curves are going to look like horseshoes, right? The sine curve has to go like up, down, and around.
Oh.
Okay, so that's kind of what you're looking at when you look at one full curve.
Wait, so, okay,
That's all right. All right, let's see if you guys can get this one. Which equation? A little bit trickier. And again, you can match it up onto your, if you actually physically wanted to graph these, you could. On your calculator and kind of match it up and see. First thing I do is figure out is sine, cosine.
What do you think that was?
That's an easy time to like see which one's which by the time I look at all. Okay, what'd you guys get? 1, 2, 3, or 4? 3? Good job. Right away we can tell not a sine because it's not starting at 0. Okay? And just like the sine one, do you guys remember yesterday when the sine happened, if it was negative, it went down first? So cosine, when you guys have a negative in front, it just starts at negative, which is kind of cool. And you have 1, two curves. It's just weird because it's flipped, because it started at that negative, not the positive. But they're still looking at like horseshoe shapes. How are you guys doing so far with this?
That's pretty good.
Not
Is it gonna get harder?
No, this is it. Like the next 2 days, we're literally just graphing things on a calculator and matching. These next 3 are a bit tricky because of the interval. All right, that you guys have. And if they're going to put something harder, usually it's because they're trying to trick you up with which choice you're going to pick. Right. So, did you guys already do 6 and 7? Some of you? Right, so I think you did this one.
Oh,
If you think you got it, go for it. I just want to make sure you think. If you want to do 6, 7, and 8, and we'll talk about it. See which ones you guys think. I'll go over 6 in a second. So just pay really close attention to this part. It's only going, not to 2 pi, it's only going to pi. So be careful. It's trying to be tricky.
I can't read the second numbers.
Good. Yep, exactly. That's how they're going to try to trick you. But what it would look like.
Okay. So that doesn't make sense. Why?
Right.
I don't like 7. I don't like 7.
I know, these are hard. Okay, so let's talk about 6 first. Is 6 going to be a sine or cosine curve? Cos. Starting at 1. We don't even have sines in there, so that's fine. Now, the amplitude, if you guys kind of cut this down the middle, what's the amplitude here? 1. Okay, so we can get rid of that one. The tough part about this is the interval. Now, on this part, the b value, the frequency, shows you how many full curves between 0 and 2 pi, right? But we only have to pi. How much of the curve is showing right now? Yeah. So if you kept this going to 2 pi, a little bit, okay, how many full curves would be there? 1. Nice job. So it has to be choice 1, where the b value would be 1 here. Right? It's very tricky. Because when you look, you're like, oh, I just see half the curve. That's it. But it's because you guys have to look between 0 and 2 pi for the b value. Very tricky. Yeah.
All the time?
Yep.
Can you write one more? Because it's looking for a full one, or just full one function time. Would you do like more like?
Wait, say it one more time.
Like what if there wasn't a full curve before 2? Like this is like really big.
It was not a full curve before the 2 pi. So like if you had stuff like here.
Like at like 2 pi, it would like half of the curve. Like not.
Oh, I got you. Okay. So like if it was like that or a little bit more. No, you won't see that in this stuff. So what Julia's question is, could you have something, so basically like I moved the 2 pi out and it was like maybe like a little bit like something like that maybe? Is that what you mean, like 1.5 kind of?
No, I mean, cause like, maybe I thought the whole one, or like ever, like could the half point of the curve be at the 2 pi?
Oh, yes,
That's
sorry.
why there's like a 1/2 option.
Yeah, okay, so let me show you what that would look like. I got it now, sorry Julia. So if you had, it would almost look just like this, except bigger. 1, 2, 3, 4. So it would look like this. Or this would just be your 2 pi. That would have been a half. The frequency, that b value, is always how many full curves you see between 0 and 2 pi. That part never changes for what the D represents. So when you look at the frequency of something, whatever this number is, right here, that's always how many full curves you see between the 0 and 2 pi. That part never changes, always 0 to 2 pi, no matter what. And some of these get kind of tricky. Let's look at, we do 8 first. Oh no, actually, never mind, we'll do 7.
7's
Okay. Alright, 7 is very difficult. Okay, because there's a lot of tricky parts in them. Can we tell if it's sine or cosine?
Yes.
It's going to be cosine, great. We're starting at 2. We're going to get rid of the sine. Okay, so now look at your interval. And someone asked us if it was always going to be pi over 2. You know what I mean? When when you have to physically graph it, it'll be nice. But something like this could happen. Now, with this cosine curve, can we tell what the amplitude is? 2, good. Gotta be 2. That's not too bad, right? Put it through the middle. You look how many points we got up and down. Right. The amplitude's gotta be 2. Alright, let's look to see. How many full cosine curves do we see here?
1.
So we only have 1. Remember, cosine curve is like a horseshoe.
But it's not 2 points.
Exactly, Carly. Good job. Very nice. Alright, now this is tricky because look, usually when we look to see what the frequency is, what the B value should be, we have to look between 0 and 2 pi. Now, we kind of did a problem like this the other day. You guys asked a good question, but there's an easier way here. Does anybody know in something that we've learned to show you guys how long it takes just to see one full curve? The period formula. Good job. Nice work. The period formula is the length of time it takes to see one full curve. So if we use 2 pi over the b, the length of time that it takes you guys to see a full curve, they're telling you it's 2 pi over 3. That's what they just told you. That's how long it's going to take us. So what does the b value have to be there? It has to be 3.
Because then you realize that it's not 2 pi, but it's 2 pi over 3, so it's a third of the 2 pi. Well, it's a third of
Right, exactly.
That's
you
usually
guys,
what it's saying when I put it.
that's exactly right. We kind of did something like this the other day where this was one curve, right? And if you added another 2 pi over 3, we got 4 pi over 3. And if you wanted to get to 2 pi, if we added another 2 pi over 3 to this, we got 6 pi over 3, which was 2 pi. So there would have been 3 of those. Do you guys remember adding them like this the other day? That's it's like another way you could have done this.
So it's basically like you find out that the b is 3 and you just put it in for b.
Yeah, that's it. They didn't really want you guys to do it this way by adding things. They really wanted you guys to get the idea, looking at that there was one full curve and knowing that the period formula gives you the one full curve, and that if you wanted it to be 2 pi over 3, the b has to be 3. So, Julia, that was really, really good. Let's see if we can finish 8 real quick. Can't get to the graph, not a big deal. This is a bit tricky. Okay, so if you guys were coming up with your own equation. What?
Oh my god.
It sounded like you actually.
Yeah.
Okay, so with this curve, this is very tough. Can we tell, is this going to be a sine curve or a cosine curve? Probably cosine, and they tell you. See how they tell you right in it? Cosine curve? You know what, we're going to run out of time today, aren't we? How much time we got left? A minute? Alright, I'm going to put your homework, like, right here to grab on the way out. Back here. Okay. Right behind Frida. Just grab it on the way out. But with this problem, this would be, I think, one of the hardest type of questions you would ever see. This one is very difficult. Okay. Now, look at your curve. Does it go the same part up as it does down? No. Okay. So look at this. At the end,
You have to draw the line.
yeah, you kind of have to draw a line. But when you have something be added or subtracted at the end, what does it mean happens? It moves up and down. So
mine all we do is just
all right, and move it up. So yesterday, do you guys remember kind of drawing the line to split it?
Yeah.
Okay, so it was the same up and the same down. So if you draw your line, like find the middle, okay, what's really the amplitude here between all these?
3 plus 2
3.
plus 1.
Good. 3 close. Good job. 2x, because there'll be 2 of them, plus 1 is the short. Okay. I'll go over this more tomorrow. Great job today, guys. Thank you.